This is a longer section of log. This is just a big lancing section. Same kind of a format in the bottom, except as far as porosity go, I added the sonic porosity in there. And if you make the presentation that I talked about, I put that on the top. That gamma ray block that I was talking about is off on this picture, so I'm seeing a lot of green. A lot of green. Why do you think I'm seeing so much green in shale zones? What do you think that might mean, if you think about this for just a second? The fluids that you have in shales, are they the same? Do they have the same chlorides that you have in your producing formations? Probably not, right? They're a lot fresher, right? Quite a bit fresher. Well, if you made the correction to the scales, instead of reading that number, that you knew what the connate, or if you will, the formation water was, and establishing your scales, now if you rescaled it for that fresher water, that's going to all of a sudden get rid of all that green zone, okay, in the shale zones. Now you can do that, which is fine. There's nothing wrong with doing that. Or I can add the gamma ray block, which is just essentially masking off all the shales, and they just go away just by covering them up, okay? Again, I haven't made any calculations. I'm just covering up the shales, okay? Now you can do the same thing with changing the scales for that shale connate water, okay? Or you can just mask them. So now I'm looking at those, as far as figuring out where the pay zones are, I'm just looking at those that start to show up at this point now. Then these are the ones I'm going to look at. Do I need to worry about running a DST? Do I need to worry about these as pay zones? Okay? And this is how it would look like. For instance, you sent me the log. Do something, call me back. Can you call me in 10 minutes? How many times have I heard that? Can you call me in 10 minutes? I got to do something. It's all money. Time's running. And when they say 10 minutes, usually they mean 10 minutes. I'm waiting. I'm on the phone. So you do this, give them a little simple idea about a little zone, and everybody's happy. It's all great. Now let's just look at a pure Lansing comparative analysis. Again, it's the same process. Establish the scales off the header. This is in Ellis County. We now have a well that looks like this. Off to the right, I have a lot of colors. Well, in Ellis County, there are a lot of pay zones, right? The difference here that you're going to want to think right off the bat is, remember we were looking at all those greens? Green is movable. The yellows are residual. What are we seeing more of here? We see more yellow, right? We got pay zones, but, right? We got hydrocarbon, but I got to figure out, why is it all yellow? Now we have that big thing down here. Again, lots of yellow, but there is that small component of green, right, that's showing up. So now maybe I need to investigate that one. That's a big, thick zone. If that's a pay zone, I'm in Ellis County, I'm good, okay? It's got good porosity. You look at the porosity, there's, averaging 13, 14%. If you look at that log, it's got a little bit of secondary. Doesn't have a lot, but it's got some. So maybe that's the one that I wanted to look at. What's the other thing? I haven't talked about this yet, but because of this presentation, these will always do this. If you just look at the resistivity track, okay, again, I've just scaled these from 0.2 to 200 just for ease, because it keeps the curves mostly on the page. Well, I've got the dual induction logs, and you see the ones with the blue shading, that's the microlog, okay? Where is the microlog in general opposite these zones of apparent pay? It's off to the left, right, of the resistivity curves, the other resistivity curves. We're back to that, what was the microlog called in the beginning? It was our first porosity device. So I got porosity to the left, resistivity to the right. Got another quick look going on over here inside the resistivity track, right? So if if I'm doing that, then my interest is these things like up here, 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 here. In the back of my mind, I want to follow those as I look up and down the log. I want that effect to start with before I ever get to anything on the right. That quick look. Resistivity to the right, porosity to the left. But now I'm looking at that big fat zone at 3715. It runs down to about 32. And that's probably where I want to concentrate all my efforts. Okay? Because it doesn't have a lot of green, but it's got green. It's got movable. Now when you're looking at a lot of reservoirs, not just Kansas, but typical reservoirs, what kind of movable component do you expect to see? What percentage primary recovery do you get, for instance, when you produce a well in Kansas out of a limestone? 10, 15, 20%, right? Now as the reservoir gets better and better, that becomes a bigger number, right? So this movable component, you can imagine it not being a great big component in a lot of reservoirs. It just depends. Well, there between 37, 10, and 20, I've added the perfs that they picked for this well. Basically, they perforated it from 3714 to 17, and it's water-free. And it's making a lot of fluid, just like you would kind of expect it to. Now, I have all those other zones up the hole that I can worry about later, right? Unless you're real greedy, which we tend to be in the oil business. But now I have the first zone to work with. Whatever I've done has matched what has happened, okay, in the interpretation process. It's matched it. Looked like it should be water-free, never calculated a water. Now I can make the calculation. This is what it would look like for one of my interpretations. You have that bulk volume water track that John talked about earlier going on right here, and this zone is mostly green in there. But if you just calculate the water saturation, that's out here, and you see that it's a very, very low number up there. It runs between 20 and 30% water, okay? So the match is there, the match that we saw on that previous look versus this look, okay? And there's the perfs again, so you can see that that's where you would have picked them. If you went through to that stage, you're always going to pick them in the same place, right? Now let's look at an Arbuckle through the same analysis process. Now we've got dolomites that we're working with. So when we look at the porosity curves, the neutron is going to be quite a bit higher than the density, right? That's a typical Arbuckle type display. You've got that separation going on because of the lithology effect off that cross plot that we saw earlier. So this response that you see, it's not very exciting, but it's always showing that. The curve that's changing in the porosity realm is what? It's the sonic porosity that's changing. So as it's going up and down, what's happening to the secondary porosity inside the Arbuckle? It's going up and down, right? So always keep that in mind. We've got the quick look on the left with the microlog and the resistivities. So I see that I better be interested because there's that gap in there. So now when I present it off to the right, and now I've calculated just the average porosity to kind of get rid of the neutron density. I'll just put the one curve in there, which is just the average. Do the same overlay. Start looking at that Arbuckle from the bottom up until I get to about 3815 or so. I'm not seeing any change, any separation. And once I get there from that point up, they stay separated, right? But let's look at that sonic out there, because this is going to be important, especially in an Arbuckle evaluation.